Hi and welcome back to chemistry. Now everyone loves a fire, and a fire is a type of a combustion reaction. In the case of a general fire, we are looking at burning a fuel, and in most cases your fuel is your wood and you're burning it to produce heat. Heat is a byproduct of all combustion reactions. So when we talk about combustion, what exactly do we mean? So when we talk about combustion, combustion is another name for burning. And when we're burning, we are burning in oxygen. So all combustion reactions that we're going to be talking about is a reaction where we have a substance burning in oxygen. So our reactants in this case is the substance that we are burning and the oxygen. Most things that we burn are our hydrocarbons. If you think of our fuels, such as our petrol, octane with regards to our high octane fuel, methane, the gas that we burn in terms of our natural gas that we use to heat our homes, and as I said before, our wood. Now, most combustion reactions, the whole purpose of them is to produce heat, and that is an exothermic reaction. And we'll talk a little bit further on exothermic and endothermic reactions later in this course, but exothermic reactions give out heat. So again, that goes back to that chemical reaction and signs of a chemical reaction that we talked about before, which is a change in heat. Another product of our combustion reactions is they produce light. So we will often see a flash of light as they're burning, or in the case of fire, it gives off light as another form of energy of that reaction. Again, energy is not created nor destroyed. You should have remembered that from year 8, but it's just transformed into another form. So when we're lighting our fires, we are producing heat, which might be our main reason for lighting the fire, but a secondary form of energy there is our light. Now, the type of light we get will depend on the amount of oxygen that's available. So if you think of our Bunsen burner flame, when we have the hole closed, there is reduced oxygen there. And with that reduced oxygen means we're having an incomplete combustion. So we're not getting all of that oxygen burnt because we don't have enough oxygen. So we don't have all that fuel being burnt because we don't have enough oxygen there. So we call that incomplete combustion. And if you heat a piece of glassware or a beaker of water on the yellow flame, you would have noticed that it does produce soot, and that's a byproduct of that incomplete combustion. In contrast, if you open up that Bunsen burner flame and we have the hole open, more oxygen's allowed to flow in there, and we get then a complete combustion forming, and we don't get that soot forming on our glassware when we're heating. So when we have our combustion, we are producing heat. We've mentioned that before, and usually we are getting, depending on, of course, what it is we're heating, but if we're heating an organic substance like wood, or in your demonstration that we're going to look at, we will have our ethanol. You will find that we produce carbon dioxide and water. So we've already talked about the presence of condensation, that's the water, and the soot will be that black substance that we find on the outside of the glassware or the container that we're burning them in, and again that's due to that incomplete combustion. So you'll do a couple of reactions in class to test that combustion. Another one is the traditional heating of magnesium in oxygen. And if you remember back to the salts that can be formed, in this case, if we've got magnesium burning in oxygen, remember when we burn in oxygen, we form oxides. And salts that are formed with oxygen, the first part of the name is named after the metal, so in this case we might have magnesium, and the second part of the name comes from the oxygen, and in this case it'll be oxide. So we're going to look at a couple of different reactions of combustion reactions in class, and we'll talk about that naming a little bit more. See you then.